So the last class we had discussed about network programming, in which I told you about transmission, how transmission happens. That is what we have seen. Okay, we'll go ahead today. So last class we have seen introduction to TCP data transmission. What is the core purpose, prerequisites, all these things we have discussed. I'm not going to touch. But if in case you have some doubt, you will ask me. Or if there will be something very important to tell, I'll tell you. The three-way handshake also I've explained. There is buffering mechanism employed in handshake. Remember that. Then I told you about the four core mechanisms. Divided the TCP description about TCP transmission into four core mechanisms. The reason is that code is also split into these four mechanisms, four functions actually, threaded functions. Sequence numbers, I told you that every segment and is sequenced, and every byte inside the segment is also offset. The sequence number, how it works, I have explained to you last class. All these things we have discussed. Sequence number calculation also, I told you how the calculation happens. You remember that? Accumulative acts also. Sometimes, suppose you give act number 1500. Okay, means everything below 1500 till 1499 have been accepted. So that is the accumulative acknowledgement that happens in TCP. Now here, this is here we were last session. Handling lost packets. So many packets are being transferred. Some packets will certainly be lost. In the real world physical networking environment where so many data is being transferred and from so many sources to so many destinations. So many dedicated connections are established in the same network. Data packets frequently get lost. Entirely due to service network congestion, traffic, fragmentation, defragmentation, due to these reasons. Hardware routing failures are also there. Some hardware malfunctions happened, or random transmission errors happen due to some interference. TCP will implement a robust transmission mechanism which is strictly governed by internal timers. Timers for packet sending and receiving, and timers for acknowledgement. After sending any data segment, whatever data segment has been sent, the sender immediately starts a dedicated countdown clock known as a retransmission timeout, RTO, short form, timer. If the sender completely fails, to receive any acknowledgement within that RTO, it will retransmit it, considering that okay, the transmission had failed. Okay, this is a retransmission mechanism. It assumes that the segment was lost during transit and the acknowledgement is late, and then it will send it. The sender automatically retransmits whenever there is a timeout or acknowledgement. This is a very common thing that's known to everybody. Network reality is that packets are routing lost via severe congestion or hardware errors. Fine. Timer reliance is there with respect to sending data and with respect to acknowledgement. TCP heavily relies on dedicated transmission timeout RTO timers. Now, what are these timers implemented as? Wall clock time or some other timing mechanism? Well, it does not rely on wall clock timing. It relies on system timing. The unit of time in system is not seconds, it is GPs. I'll tell you about GPs and timer management in device groups. Trigger mechanism. The sender starts a strict timer immediately upon dispatching the segment, and expired timers forcefully trigger an automatic segment retransmission. Okay. So network is a another place. Packet losses are common feature. The receiver will have intake queue and a timer. The signed acknowledgement must go within the time. If timer expires, RTO, then retransmission will happen. These concepts, we have to be very clear about that when we discuss about some TCP anywhere, or later on when we can implement TCP. So until we know the concept, we will not be able to implement anything. Okay, we will not know what to implement. Yes, Punindu?
Is there any kind of a standard time defined like threshold value for that the timeout to be calculated for the segment?
Yes, 1st January 1970. 1st January 1970 was the beginning of digital time. Like the wall clock calendar started in 0th century BC, after AD, whatever. The digital time started on 1st January 1970 and it's called EPOC. EPOC. Actually, you can check Google for this. EPOC converter. What is EPOC? A particular period of time in history or a person's history. EPOC date. In machine learning. Full pass of entire training data sheet. No. EPOC in digital. Oh, in times of AI, the Google appears to have different meanings for it. I mean, how could we modify? EPOC is a significant point in time, particularly in the area of technology. It often marks the start of a new era, development and version. This is AI, changing the meaning of actual things. EPOC meaning in digital and date. First January 1970, there it is. Unix EPOC. The most common standard or is January 1, 1970 at this is UTC. This is the beginning of digital time. So the system times that we use in our computer does not follow the wall clock time, hour, minute, second, Sunday, Monday, January, February. No, it follows this time. Okay, and I'll tell you that I'll show you in device hours when we implement timers that this is the time that is followed in your computers. It does not matter for a computer whether it is at 2 a.m. or 2 p.m. It is January, February, December, 19, whatever. It does not follow the current at all. Okay, and unit of time in EPOC is degrees. Unit of time. Standard. Standard is microsecond, nanoseconds, but in computers it is not that. So people are just writing anything. I'm not convinced. Anyway, since we have spoken about this, I'll show you. This is the LTI. Where are the LTIs? This is GPUs. on all the 12 cores, the count of GPs. My system is on since these many GPs. If I give this command again, see it is unit 100,000, 10,000, lakh, 10 lakh crore, 176,000, 176 lakh 64,000. It becomes 176, 73,000, 75,000, 76,000. So did you see that? GPs is going on very fast. This is the actual time calculation that happens in our computer. Okay. Then there is software written in operating system that converts these GPUs to human understandable generic memory time. That's how it goes. TCP uses this digital time, which starts at epoch 1st January 1970. It does not follow the world clock. And the timers that I told you are also in GPUs, implemented through digital times, not the world clock. Because internet latency is highly variable and unpredictable. Utilizing a static timeout timer will be very inefficient. But this GPUs, as it is set up duration in the computer processors, is fixed. Like you buy a watch of any brand, you will see that it will have one common duration per second, isn't it? Similarly, every processor have that common duration per second. TCP will incorporate, we will incorporate through TCP a highly adaptive transmission algorithm that will calculate the RTO based on that the digital timer circuit which is there in every processor. Okay, and we'll set it up. There is no standard time. It is called round trip time. RTI, there it is, round trip time. So which will be set up by us depending on our device, depending on kind of network we are connected to. This is a very intelligent design. It ensures that the timer constantly adjusts to shifting real-time network conditions. Suppose the congestion is more, then we'll adjust the acknowledgement timer to a little more. Your sliding window is big. That means so many packets are coming. Then your timer will come down. It's very intelligent timer. That's why I call intelligent timer. Sudden increase due to transit network congestion will happen. Extend the RTO to bigger limits. Window is big. That means there is no congestion. RTO will become less. So RTO is not static. It adapts to live network conditions. It is always derived from continuous RTT, round trip time, very important constant, variable rather, metric measurement. RTO increases during heavy congestion and decreases when there is no congestion. The timer is dynamic. Dynamic RTO timer. There is continuous RTT measurement happening that keeps on balance between the traffic, network, congestion, and the RTT. It increases or decreases depending on network conditions. Congestion response algorithm has to be written, which works parallel to the TCP. And this algorithm keeps on feeding the TCP about what is the situation of the network. Okay. When it is heavy or it is light, so this will keep on giving us information about the network. Accordingly, we'll set RTT response time. Okay. There's something called ACKs, selective acknowledgments. So what we know right now, what is in our mind, that for every packet that is coming from network, we are giving acknowledgement. Packet acknowledgement, packet acknowledgement, packet acknowledgement. That is what we know. But there is something called selective, something called accumulative. Accumulative, I have told you that you give 1500, that means everything below 1500 is received. Nothing is missed. But there is called selective. While accumulative acknowledgements are generally quite efficient. You give one acknowledgement number 1500, so that means everything below 1500 is received. They possess a distinct architectural vulnerability. A problem. If a single segment is lost in a massive stream, single segment is lost, the sender might be forced to needlessly retransmit of subsequent numbers. Suppose you're sending at the step of 10, 1, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, like this 1500. But something maybe 440 is skipped. So only because of that 440, it will not send 1500. So the sender is not sending 1500 means everything below 1500 is not received because only because of one packet that is 440. And on the other hand, the sender is having this bad impression that only till 430 it has gone. What about the rest of the things that have gone beyond 430 to 1500? Whereas only one is lost. So sender might be forced to needlessly retransmit all subsequent segments because ITT, timer is gone, timer is expired. So those that are arrived safely will also be again re-arriving, and a retransmission will happen. So to permanently resolve this inefficiency, TCP supports a critical modern extension known as selective acknowledgement, SACK, SACK, as you see there. It actively empowers the receiver to inform the sender about exactly which specific segments were received successfully or not. How it works is, you give, suppose 440 is lost, you give 410, 420, 430. Sometimes it is assumed that the network congestion is very heavy. Network congestion is very heavy. Heavy network congestion. So you don't send acknowledgement for every packet. You send acknowledgement for 5 packets. So you're sending 10, 20, 30, 40, 50. You'll get acknowledgement only for 50. You get 50 means you have everything from 10 to 40. Then you send acknowledgement 100 means everything till 100 is gone. 440 you got 400. Then you're sending 400, 10, 20, 30, 40, 50. But you don't get acknowledgement from 50. Then you send 60, 70, 80, 90 to 500. You get acknowledgement 500. So it knows that okay, 450 acknowledgement is not come. That means there is something wrong between 410 to 450. So only 5 this will be sent. That is selective acknowledgement. Okay. The granularity of acknowledgement is not every packet. The granularity of acknowledgement will become every packet when 410, 20, 30, 40 will be sent, 50 will be sent again. There it will acknowledgement every packet. Acknowledge every packet. Unnecessarily it will not acknowledgement. It is read in theory that it acknowledges every packet. Fine. But there is a quantum of, in our example, you have taken a quantum of 5. So somewhere it does not get acknowledgement for one quantum. That quantum is retransmitted in which they get acknowledgement for every segment. That is how it is made efficient. Okay. Standard ACK can easily force redundancy. Wasteful transmission, retransmission, unnecessarily one full stream will be occupied only for acknowledgements. SACK allows the receivers to acknowledge highly specific out-of-order blocks. Like you have got your 500, then you come back to take care of 410 to 450. The sender only transmits the exact specific segments that are missing, and those retransmitted segments are acknowledged. Massively improves overall throughput on network experience. Mild packet losses. Packet losses are mild, but it doesn't mean that for mild packet losses you'll have acknowledgement for. It is just like having a page number for book, it's fine. But if you give word number to every word number to every book will become this big, isn't it? Similarly, the concept of SACK was introduced in TCP, and selective acknowledgement is done for quantum of packets. If some quantum is missed, that quantum is retransmitted. Size of the quantum is again agreed upon value between the TCP protocols running on receiver and transmitter. Just like sliding windows decided, that quantum size is also buffer. It is said buffer size is also decided. How SACK works? Well, I've already explained you how to. Sender activity dispatches 1000, 1500, 2000, 2500. Failure point is 1500. Okay, but you have received SACK for 200, 2500. Okay, so what will happen? So only till 1000 to 1500 will be retransmitted. That's how it works. And that's what is explained. Only particular ACK is missing. Only that will be quantum will be retransmitted, not everything. I think the concept is understood. SAC concept. Now, flow control. Sender will always have restrictions. Sender will always have restrictions. What are the restrictions? Restrictions are imposed by two factors on the sender. One is the network, one is the receiver itself. The receiver will have window advertisement that will be conveyed to the sender at a regular interval. Depending on the sender will adjust the window. That is one restriction that is applied by the receiver. The network-based congestion, restriction, we will discuss later. While ensuring reliability is paramount. Reliability is something which is the most important. Reliability with respect to things. Every packet must reach. Second, every packet must reach in given time. TCP must also actively prevent sending device from swamping the receiver with excessive and unmanageable flood of segments. This regulation mechanism has to be set up between the sender and the receiver. I've told you earlier it is done using sliding window protocol, whereas the receiver will keep on advertising how many packets I can handle. Sender will always send less than that. The receiver dynamically advertises. Dynamically means every time, now and then, now and then. If there is no change happening in its state, it will not advertise. The sender is strictly bound by this advertised parameter and must ensure the total volume that is sent and acknowledged should be less than what the receiver is advertising. This is flow control, and this is the only flow control, and this is very, very efficient. TCP. Yes, Punendra?
सर नहीं समझ पाया मैं फ्लो कंट्रोल.
Yeah, I already discussed. I really explained this to you. So what is the problem? What is causing problem to you?
नहीं, बीच में मुझे कॉल आ गया था तो एक सेकंड मुझे मैंने जस्ट रिप्लाई किया तो मैंने नहीं सुन पाया.
I was just explaining the handshake, the agreement between the sender and the receiver, because
वो तो एक्नॉलेजमेंट और सिंक एक्नॉलेजमेंट और सिंक एक्नॉलेजमेंट के थ्रू होता है ना.
Sync is that's a handshake.
हाँ.
This is sliding window. The receiver will keep on advertising how many maximum number of segments I can handle.
Yeah.
Accordingly, the window will be set up.
Window size will be adapting itself.
This is flow control. This is the only flow control that happens in TCP, and there is no other flow control. Okay. And this is very efficient. So the receiver and the sender, because of sliding window protocol, the receiver and the sender are always in sync about how many I can handle, how many I am sending. That's a perfect sync between these two. Now another thing is congestion control. Oh, there are so many reasons. Suppose you have the sender and the receiver just started communication, and the receiver says I can handle n number of segments. So create a window of size n. But the sender will do slow start. Slow start. So as to avoid congestion. Network is established, but not yet started to use. Because not yet started to use, therefore, there is every chance that somebody else is already using it. Strictly protects the underlying shared network from total traffic. If it starts sending all the messages that it wants to at the same time, then there is a chance of crash. Standard flow control strictly protects the individual receiver endpoint. Congestion control is completely dedicated to protecting the broader network and components in the better, the shared network infrastructure. It is working at a low bandwidth, low data, and suddenly you send so much data, so that will cause like waking up somebody from by giving a tight slap. So slowly start happens. If the receiver says it can receive n packets, you send n by 2. It's like gradually grow. This way you are doing congestion avoidance by increasing speed slowly. Okay. Then second thing is acknowledgement doesn't come back for every packet segment. Acknowledgement come for every quantum of packets. Okay. Flow control, congestion control algorithms both focus entirely on the network's total carrying capacity. And the capacity is not fixed, it is varying. And TCP says it will never go above 0.8% of the capacity unless you're sending urgent packets. TCP achieved this very highly delicate balance using mathematically specialized algorithm like slow start and slow start, congestion avoidance, which are underlying both, and retransmission. Fast retransmission also has to be put up here. That is not. So third thing is why I'm telling third thing particularly because इनके तीनों के algorithm है, इनके function लिखे जाएंगे. Slow start number 1, then congestion avoidance, and then fast retransmission. Okay. Whenever there is packet loss, retransmission will happen. Anyway. So operates concurrently with flow control, but strictly targets capacity, never reaches capacity. Maximum it goes 0.8 of capacity. Utilizes sophisticated algorithms like slow start, congestion avoidance, and retransmission. Senders actively probe network limits and rapid back off upon packet loss. And whenever there is packet loss, retransmission happens. That retransmission is also one thread that is run within TCP. So these three threads will run continuously: slow start, congestion avoidance, and retransmission. These three will run permanently and will ensure that network is never cleared. Okay. Slow start. It provides an absolutely excellent example of TCP congestion. Okay. When the beginning happens, in the beginning, when the connection is established, then what happens? TCP intentionally starts with a drastically restricted congestion window. You said n, okay, I'll start with n by 2, allowing only a single segment to be actively transmitted. Sometimes the window size is only 1 in the beginning. Okay. As acknowledgement starts coming from the transmitted packet, slowly it will grow. This window size will grow and more transmission will happen. TCP will increase the congestion. Window size will increase. Okay. At an exponential rate. Okay. Once inevitable, like once it's inevitable, then okay, all the packets are now being acknowledged, then you go to the 0.8 capacity. But you'll never go to the maximum capacity. Never. The connection begins with the intentionally minimal congestion flow. And it grows slowly. The window size grows slowly. Rapidly scaling because more and more acknowledgement comes, more and more window size increases, more and more speed increases. And there is always a chance for reset. A reset back to n by 2 can happen anytime. Suppose there are some significant packet losses happen, maybe 1%. Oh, that's big. It will reset to n by 2. The reset algorithm is that. Okay. So that was flow control. We are not discussing implementation right now. We are discussing बातें कर रहे हैं. Just storytelling happening, in which I'm telling how this TCP is working, how the flow control is working, how the handshake is working, and this is how TCP has to be understood. Everything that I am telling you about TCP is not fixed. It's a non-standard. So things vary. By the time we finish all this discussion, all this talk, we'll have a fairly good idea about how TCP works. Then when time comes, we'll ask. We'll ask questions and we'll do implementation. Yes, Pulendra, tell me.
सर आपने कहा था एक्नॉलेजमेंट तो पर सेगमेंट नहीं आता है बट फॉर per
Can you repeat
quanta.
that? Could you please repeat that, please?
Yeah, sure, sir. Like you said, like the acknowledgement does not come for every segment; it comes for the every quantum of.
Quantum of segments.
What was that? Is it like a group of packet segments will have the acknowledgement?
Suppose
So you are not.
suppose you're sending segments like this. Suppose you are sending segments and the acknowledgement will come. Segments are going with the step 10. So segment number 10, 20, 30, 40, 50, for 50 you send acknowledgement. That is called collective acknowledgement. Means if you send acknowledgement for 50, means everything below 50 is received. Then you send 60, 70, 80, 90, 100. 110, 120, 130, 140, 150. You get acknowledgement for 150. Now you did not get acknowledgement for 100. So the sender knows that within that quantum of segments, 60 to 100, something is missing. Retransmission will happen for 60 to 100 and every packet, every segment will be acknowledged. That is selective acknowledgement. When I was sending acknowledgement only for 50, only for 100, only for 150, only for 200, that is called collective acknowledgement. Now, after that, there is something is missing, some quantum is missing, then you retransmit the whole quantum, and every segment inside the quantum is uh, acknowledged. That is called selective acknowledgement.
तो सेलेक्टिव के केस में वो सिर्फ जो पैकेट सेगमेंट मिस हुआ वो रीट्रांसमिट होगा बट इसके केस में हमारे एक्नॉलेजमेंट के केस में पूरा
when the retransmit will happen, then every segment in the retransmitted quantum will be acknowledged. Very nice. Any more doubts? Please ask me now. Guys, come on. There's so much to discuss on this. Yes, Purendu?
आपने स्लो स्टार्ट हुआ बताया और ये कंजेशन और ये फास्ट वाला अभी बाद में करेंगे डिस्कशन.
No, there is nothing more. It is only that slow start means the rider, the sender
Initially, the window size will be less.
possible. The standard, not standard, but usually it is taken up to be n by 2. N is the window size given. Okay, and then it starts slowly, speeds up as more and more acknowledgements come.
सर आपने बोला ना ये तीन एल्गोरिथम और 3 थ्रेड हमेशा रन करेगा हमारे लिए. मतलब तो अभी आपने
congestion control and slow start.
Okay.
These 3 threads will run permanently. So we'll do next is our flow control only. We are going in depth in flow control next session, where all these 3 things will be discussed in detail, greater detail. Today I told you data transmission. Tomorrow we'll see flow control, in which I tell you details about these 3 things, how they work in sync with window size. Okay, that's the next topic to be discussed, flow control. The document for this is already prepared and is uploaded for your reference. You can read that. It would be better if you read it before coming so that you can ask quick questions. Okay? So, chalo, that's what I got for today. I'll catch you people tomorrow. Tomorrow there's project. Don't miss the project. Projects are more important than these sessions because only when your project will be visible and acknowledged by EmbLogic, every people, like everybody, like when they do project, they are there are many ways of acknowledging because of the world of connectivity today. It's just a matter of one phone call, and one mail that people get it acknowledged. So once your projects are acknowledged, then you will get a very serious calls. But if there are no projects, So you'll keep on applying and you'll keep getting calls from testing, support, these companies. Okay. So until your projects are acknowledged, you'll never get call from development firms. Right? So do the project so that you could acknowledge it. If you'll do fake acknowledgement, then people will give low rating to employee because these people give us acknowledgement. Okay, so we'll not give any fake acknowledgements. Once you do the project, we'll say you've done. If not done the project, we'll say you've not done. Okay. So chalo, that's what I got for today, and see you in the next class. Take care, bye.
Good night.
सर से क्या बात हुआ है?